Hey you guys, we're in chapter 10 and we're looking at section 7. Our main objectives here, even though there's 3 listed, we already know how to find the area of a circle. We know the formula for that. Area of a circle is equal to pi r squared. So the other objectives that we want to focus on are finding the area of a sector of a circle and finding the area of a segment of a circle. So some vocabulary for us. A sector of a circle is a region bounded by an arc of the circle and 2 radii. And notice it says slice of pie. It kind of looks like a slice of pie. To write a sector, you write it just like you would an angle, except for you're going to use all capital letters. So sector RPS, where it starts at one endpoint, it goes to the center, and then it goes back to the other endpoint. So notice again, it's all capital letters. That way we don't confuse it for an angle. Now a segment of a circle is the area bounded by an arc and a segment. Now the segment is going to join the endpoints of the arc. Here's our segment of a circle. Alright, so now let's find the area of a sector of a circle. To find the area of a sector, we're going to take the arc measure, divide that by 360, and then multiply it by the area of the circle, pi r squared. So this is the formula that we want to use. Alright, so let's look at our example. It says, what is the area of sector GPH? So GPH, here's our sector right here. It says, leave your answer in terms of pi. Alright, so we're going to take the arc measure, which is 72. We're going to divide that by 360, and we're going to multiply this by pi radius. Our radius is 15 squared. Alright, well 72 over 360, that reduces. We can divide both top and bottom by 72, so that's going to be 1 over 5, so 1/5 times 15 squared is 225 pi. And now 1/5 of 225 is going to be 45 pi. And it says leave your answer in terms of pi. So our area of sector GPH is 45 pi centimeters. And since we're talking about area, it's going to be squared. So here's our answer. So now you try. It says a circle has a radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? Leave your answer in terms of pi. This vocab right here, minor arc, a minor arc is just an arc that's smaller than a semicircle. So remember, a semicircle, the arc for that would be 180 degrees. So since this says it's a sector bounded by a 45-degree minor arc, well, 45 degrees is smaller than 180, so it's just using this vocab of minor arc right here. So nothing to be concerned with. Go ahead and try this problem. Now let's find the area of a segment of a circle. Now, in this key concept right here, the area of a segment of a circle is this area right here. Now, what we can do is we can find the area of the sector, we can subtract the area of this triangle, and we're left with the area of the segment. So that's exactly what we're going to do. So in our example, it says, what is the area of the shaded segment shown at the right? So we just want to find this area right here. So first we're going to find the area of this whole sector. So area of sector, we're going to find our area of our sector, ACB. And remember, to find the area of the sector, we're going to find the measure of the arc AB, which is 60 degrees. We're going to divide that by 360, and we're going to multiply that by the area of the circle. So pi, our radius is 18 squared. Well, 60 over 360, that reduces to 1 over 6. So we have 1/6 times pi times 18 squared. 18 squared is 324, and then we have pi. And when we reduce that, I'm going to bring it up here. 1/6 of 324 is going to be 54 pi. So 54 pi is the area of sector ACB. I'm just going to kind of box that in so we don't lose track of that. So that's our first part. Now we're going to find the area of the triangle formed. To find the area of the triangle formed, that's a little bit trickier. This triangle right here, we see this is 60 degrees, and then these two sides are both radii, so they're congruent to each other, which means these angles are congruent to each other, which means they're both 60. So we have an equilateral triangle. To find the area of the triangle, though, we have our formula. So we're going to say area of triangle. And our formula for that is 1/2 base times height. Well, we have the base. We have to figure out the height, though. So if we say our base is 18 right here, to figure out our height, that's pretty simple because now we dropped an altitude, which is 90. So we have a 30, 60, 90 triangle. So this is 30 right here. And half of 18, this half measurement will be 9. And that's my short side. So using our special triangles, my height is going to be my short side times the square root of 3. Alright, so our area is going to be 1/2 times my base, which is 18, times my height, which is 9 square roots of 3. And when I multiply that out, half of 18 is 9, 9 times 9 is 81, square roots of 3. Alright, so now I'm going to take my area of my sector, 54 pi, and I'm going to subtract the area of my triangle, 81 square roots of 3, and that's going to give me the area of my segment. So I'm going to put that in my calculator, and I'm going to round. I get 29.349888788, so I'm going to round it to the nearest tenth and say the area of the shaded segment is about 29.3 inches squared. And here's my answer. Alright, so now you try. What is the area of the shaded segment shown at the right? Round your answer to the nearest tenth. So follow the same steps that I followed up here. Find the area of the sector, then the area of the triangle, subtract those, and you'll find the area of the segment. Once you're done with this problem, we're done with this section, and I'll see you in class.